Okay, so here you go now. So we have 2 more minutes. We'll wait on that. And I've started recording. Yesterday I forgot recording, but I have given you old video, no problem. Every day remind me at the very beginning of the session to record the class. Sometimes I'll forget. So today I started immediately once. Okay, last class, what are we discussing about? In the last class, yeah, we were discussing about creating new implementation application on top of an existing framework, and we did the practical part of the same. So how to create an implementation application on an existing framework, okay, using new application wizard. That's what we did it practically. Okay, we are done with that practical part. And after the practical is over, we have logged into implementation application, and thereby we have seen 3 applications are loaded. So if you log into implementation application, you will be able to access implementation as well as framework as well as Pega rules, process commanders, Pega platform. If you log into framework, what you will be able to access? Framework and Pega platform. Framework cannot access implementation in reverse. That is not possible. Okay. Can one implementation access another implementation? So one implementation cannot access another implementation. That is not possible. That is not possible. Okay. So let's go ahead now and look at this. Here you go. So before we proceed to work on anything, okay, before we create any functional components or anything, so we need to understand about object-oriented programming system concepts, because Pega is built based on Java technology for its internal coding purpose and all. So its engine, everything is built based on Java. Even whenever we are going to develop some of the things, we need to follow Java concepts. Actually, those are not Java concepts. Those are object-oriented programming system concepts that are being utilized by Java, C#, what else? Java, C#, C++, and VB. Many programming languages are built based on object-oriented programming system concepts. So that concepts we need to use in Pega also. So I'm going to explain you those concepts. What is our application? What's the application we created? Oh, yours is a new batch only, right? What is our application? Tata, na? Tata.com.
Tata Insurance.
Yes. So the first topic that we are going to discuss about is encapsulation. What is the first topic? Encapsulation. So as a developer, you should clearly understand the concept of encapsulation, and you should be able to relate the encapsulation concept into your development. Okay. So what is the meaning of encapsule? Generally, what is the meaning of encapsule? You know about capsule, right? So what is a capsule? What does it contains? What will be there in a capsule? You know about capsule? Inside the capsule.
Medicines.
Hide the implementation.
Medicine. Okay.
The medicines, it will be some. It is enclosed with that particular things. So
Okay.
everything, the details, everything will be present inside. That is, will be enclosed as will be covered. That is encapsulation.
Okay, my screen is visible to every one of you. Just I wanted to cross check with you. My screen is visible to everyone.
Yes,
Yeah.
yes,
It is visible, right?
Yes, sir.
Thank you for confirmation. If it is not visible to someone, please check from your end. Okay, please check from your end if it is not visible. Okay, so encapsulation. Okay, so capsule contains some chemical composition. Capsule contains some chemical composition inside it. So it will be coated outside. It will be coated. So we'll not take the individual or chemical composition outside and will not consume it. We'll be taking as a whole unit. We'll be taking it as a whole unit. So in this world, everything that is functioning, that is producing some behavior, anything that is producing some behavior, capsule is going to produce some behavior of treating some disease or something. Okay, so maybe the person is suffering from fever, high heat and all. He is going to take a capsule. The heat will be reduced. The behavior out of the capsule is, it is having some functional behavior. So everything that you see in this world will have some functional behavior. Okay, so everything that it is going to take some input and is going to generate some output. Suppose you take a laptop. So what does the laptop consist of? What will be there inside laptop?
CPU,
Outside
RAM.
RAM,
you have
like a keyboard, mouse, and
there.
many chips, everything.
Hard disk will be there, bus cables will be there, okay, and maybe keyboard related things will be there. Okay, there are so many things like this. So these are different components. These are different components. All these components are put together and been covered, and those are being covered. That cover you are calling as laptop. That cover you are calling as laptop. So if you want to say the functional behavior is there, you will say with respect to laptop only. You will not say with respect to motherboard, or you will not say with respect to hard disk simply. So you will say everything is being done by laptop only. So laptop is an encapsulated unit. Laptop is an encapsulated unit which contains so many functional components, which contains so many functional components. Similarly, you take phone also, same. You take your pen also, same. Pen will have, it's a cover, but actually inside that useful components will be there. Okay. You take an example of a car. Car will have car whatever that you see outer layer, outer cover, that is encapsulated unit. Okay, and inside that there will be n number of different parts. Those are working together. Those are working together in order to give the behavior to the car. Okay, so everything that you see in this world is an encapsulated unit. So you have functional components, small functional components are there. These functional components you put together and connect them and cover them, and you are going to cover them, and this cover will be called as encapsulated unit. That's how everything is being made in this world. Same way in a programming language, your programs are also going to follow the same thing. In object-oriented programming system, if you are writing a program, your program contains attributes plus functional components. Attributes plus functional components, action items, those are called as methods actually. Okay, all these put together into a single unit is called encapsulation. Encapsulation is grouping of attributes plus functional components. Encapsulation is a concept actually. Encapsulation is a concept. So encapsulation concept is can be utilized, can be taken, and can be utilized by any programming language. So a programming language, when it is being developed, the programming language may come up with utilization of encapsulation concept, or may not be utilizing the encapsulation concept. It's up to them. But it was being told, encapsulation concept was being told in object-oriented programming system. What does an object-oriented programming system says? So object-oriented programming system is going to give a feature to the programming language that the programming language should follow an encapsulation concept. Then that programming language is said to be object-oriented programming language. Programming language is said to be object-oriented. So in object-oriented programming system, encapsulation is a concept where encapsulation means grouping of attributes plus functional components together is called as encapsulation. This entire group, that cover is there, no, that will have a behavior. This encapsulated unit will take an input, and generates an output. Will take an input and generates an output. So a human being, the human body is also an example of encapsulation. So we ourselves is an example of encapsulation. So we are being covered by skin, and inside that you have so many body parts. All these are coordinatively working together. Okay, we are also example of encapsulation. So now a programming language can take the concept of encapsulation and come up with a definition of it. So that is called as class. That is called as class. So Java has developed, Java programming languages developed based on object-oriented programming system concepts. So then encapsulation will be there in Java, no? So this encapsulation in Java is called as class. Encapsulation is universal generic terminology. Class is a specific terminology of a programming language, but class is equal to encapsulation. Class is equal to encapsulation. So encapsulation concept is being implemented by using the class is being implemented by using the concept of encapsulation. By using the encapsulation. If I say encapsulation, if I say class, both are same. Encapsulation is a technical word in object-oriented programming system as a concept. Class is a technical word as an implementation of encapsulation. As an implementation of encapsulation. Understand clear everyone? So the definition is applicable here. Class. What is the definition of class? Grouping of attributes plus functional components. This functional components, okay, into a single unit, So into a single unit is called as class. Okay, so class will take an input and generates an output. Suppose if we are an encapsulated unit, then we ourselves is said to be class. Human is a class. Okay, we'll take an input of food and will generate the energy. So that's the output. And you take car is going to take an input of fuel and it is going to generate output as a movement. So it will be moving as per the steps that you take forward. Okay, and suppose you take laptop will take inputs from the keyboard, generates an output on the screen of performing something or doing something. Okay, similarly our phone, TV will take an input of signals, okay, some electronic signals, and will generate a picture as output. So AC will take electricity as an input and generates an output of something called coolingness in the room and all. Okay, so everything that you see in this world is an example of encapsulation. Everything that you see in this world is an example of encapsulation, and that is called as class. So everything in this world is a class. Okay, so class is the fundamental concept of object-oriented programming language. Class is fundamental concept of object-oriented programming language. Both are same by definition. This terminology is universal. This is specific to programming language. I can create my own programming language. I can design my own programming language. In my programming language, I can use encapsulation, but I will name it as something else other than class. That is possible. Okay, I can say unit. Simply, I can say what? Unit. Okay, it's my wish, whatever. But most of the programming language is using the term class. Okay, so it will be just like this for your information. Class and name, person, attributes. What are the attributes? Okay, otherwise you take car. Okay, otherwise you take person. So what are the attributes? Attributes are, tell me, name. Okay, these are attributes. Generally, this is programming language, but we don't need all this in Pega. We do everything without any coding. Attributes are name. What else? Age. Okay, address, etc. These are attributes. Functional components.
Gender.
Functional components. What are the functional components? Okay, liver is a functional component. Yes or no? Okay, kidneys. Okay, kidney is a functional component. Okay, so kidney is a functional component. Okay, heart is a functional component. So all these are functional components. These are coordinatively working together. So every encapsulated unit in this world comprises of attributes and functional components. So what does attributes will do? Attributes will talk about those are the things which are going to control the system. Actually, attributes will control the system. Suppose you take an example of car is going to be controlled by an attribute called as gear number. It will be controlled by gear number. If gear number is 2, the speed will be less. Gear number is 3, little bit more. Gear number is equal to 4, the speed will can increase. 5 means it can even be faster than all other things. Okay, like this, attributes will decide the behavior of will control the behavior of the encapsulated unit. Okay, suppose the functioning of encapsulated unit, the output behavior of encapsulation unit depends on mainly attributes. Only. Okay, so your behavior will be based on your age. Your age is an attribute. If your age is 3 years, 2 years, like that, your behavior will be something different. If your age is like 10 years, like that, maybe you are a little bit matured and you know some of the things, what is what and all. If your age is 18, 25, like that, then you are even much better your behavior. Age is increasing, the behavior will change. Okay, so those are attributes which will control the system. So in Pega also we have classes. In Pega also you have classes. Means any functional component that you want to create, any attribute that you want to create, you must be creating it inside the class. You must be creating it inside class. All the attributes and functional components that are necessary for your business application, you must be creating those inside the class. You must be creating those inside the class. Okay, don't compare with rules. I'll tell you rules later. Okay, you can compare with rules and say okay, no problem. Now look at here. I did not come to rules so far. I'll come to rules soon. Class and encapsulation both are same. Why we have two names? Are you there with the class since beginning? Sai Praveen Kumar. Encapsulation is a concept. Class is a simple. Encapsulation is like a raw material. Class is like a product made out of the raw material. Okay, I have a plastic material. I have made a bowl using plastic material. So that is encapsulation. This is the concept of encapsulation is taken and made something specific one. That is called as class. Understand clear, everyone? Okay, just listen to me carefully and try to understand it in a generalized way. Don't think too much about technology. You cannot learn technology thinking too much. Okay, look at here now. Here you have, when we created an application, After we create application, okay, Pega has automatically created multiple classes, not only one. It has almost created 20 plus classes, okay, by default. If you want to create a class in Pega, generally you will right click on something and here you go, sysadmin class navigation zone. You will be choosing. So we'll see how to create later. But what is the purpose of a class? See, actually class is the executable component. Class is executable component. Okay. So here you go. Class is executable component. Executable component. Inside this, there will be so many other components. Okay. Class is instead of saying component, executable unit. Class is executable unit which will accept an input, comma, process it, comma, generates output. Class is an executable unit which is accepting an input, process the input and generate the output. Okay, that's what. So everything in this world is class. I told you, we are going to consume food. We'll take input as food and we will produce an output behavior of energy. Only when we eat food, then only we will be able to move. Otherwise, is it possible? If you're not having food for 3 to 4 days, is it possible that we can move from one place to another place? So to raise your hand also, you need an energy. Okay, that energy is being produced as an output by taking an input. You're not taking input. Where is output? No. Understand? So we are ourselves a class. Class is an executable unit which will accept some input and process the input. It will be digested, converted into energy, and output will be generated as energy. Yes or no? So that's how you need to learn everything in the technology in real world. So compare with real world and learn. So means all the attributes that you define, all the functional components that you create, you must place inside class. You must place inside class. Whatever the functional components that you need, you must be placing inside the class only. So example we'll see now. Example. I want to create a bank application. Where these classes will be? Classes will be inside application. Classes will be inside application. I'll draw one diagram. Okay, look at here. Paint. I'll take paint. So I have an application. One big application is there, just like that. Okay, big application. This is application is banking application. What is that? Banking application is there. We already discussed about application. No, application is collection of functional components. Application contains functional components. This is banking application. Inside application, functional components should be there. But just now we discussed inside application, functional components will be there inside class. Which one is true? Application contains functional components or class contains functional components? Which one is true? Both are true. Look at here. So application contains classes. Application contains classes. Class 1, I will just move it here. Control C, Control V. Am I able to take it up? Okay, leave it. I'll draw one more class. Class 2 and class 3. Okay. So these three classes are meant for three different reasons. This is bank account opening. Okay, I'll write down this. Here you go. Account creation. Account creation is a specific operation in the banking system or not? Yes or no? Account creation is one specific class. And here you go. This is loan processing. What is that? Loan processing. Loan processing is also one specific operation in the business or not? In a banking business. What about this one? Insurance processing. This is insurance processing. I'm sorry, I should write processing. Okay, insurance processing. This is loan processing. Loan processing. Then imagine it in the real world. Imagine it in the real world. See, each of these are classes. Each of these are classes. Actually, it's good if I am going to move it something above. Yeah. Okay. Okay, these are all classes. These are all classes. I'll just mention that point here. Go. These are classes. If I say this is a class, means all other things similar to this are classes only. Okay, inside class, what will be there? Inside class, you have functional components. No, I'm taking this section. Tell me some functional components in account creation. Function attributes, you tell me. Attributes are
First
account
name.
creation.
First name,
Attributes.
last name.
Login ID.
I will take it as okay.
Account
Attributes
holder
are,
name.
just give me a
Account
minute.
holder name.
Name,
Creation of
account holder name,
creation
account,
of operator.
account number. These are all part of account creation process. Okay, initial balance,
PAN
initial.
card.
Many things can be there. These are all attributes. Tell me functional components.
Withdraw money, deposit money.
Functional components. I'll tell you. Deposit. Deposit is a function. Account creation only, no? Create account. Create account. Approve account. Approve account. These are all different functional components. Create account will take all the details and then accordingly it will process and present it to the manager. Manager will either approve or reject. That is another functional component. Like this, different functional components can be available in this. Similarly, you tell me attributes for these things. Attributes. What are the attributes for this?
Rate of interest. Total
Salary.
amount.
PAN number.
Loan number.
Loan amount.
Salary.
Salary and so on. Salary and so on. Other
Tenure
things
of
are
the loan.
tenure of the loan.
Tenure of the
Credit
loan.
score.
Credit score. So many other functional components. You tell me. What are the functional components?
Applying loan. Approving loan. Loan
Loan
approve.
initiated.
What
Okay.
verification?
Okay. Verification instead of
Loan
that.
approving.
Review. Approve or reject. Approval and so on. So many other things. Disbursement will be there. Okay. So many things will be there. Similarly, insurance processing also will have some functional components and all. So what are the attributes here? Okay, insurance policy number, policy number. Okay, term policy, how many years of term you want policy term, like this, and number will be there. Functional components.
Health checkup.
Client settlement.
Initiated. And let's consider some
Settlement.
auto.
Health certificate.
Okay, inspection. Okay, inspection of, if it is car, it is car. Auto means auto. Human means health checkup, like that. We call it as generally inspection. Okay.
Inspection. Yeah.
And process. And then approval. Again, here also you'll have approval thing at all. Generally, I'm just like that. So functional components are there inside classes. Classes are there inside application. Classes are there inside application. Look at here. I'm going to save this document. Oh, it's in Pega diagrams. I have to share. It's in Pega diagrams. Application diagram. Yours is 616, right? 616 batch. Okay. So functional components will be there inside application is true. At the same time, functional components will be there inside class is also true, because always functional components will be there inside class only, no doubt about it. But classes will be there inside application. Classes will be there inside application. So that's why we said in the initial phase, functional components will be there inside application. But it's not a single roof. One outer layer is there, that is called application. Get inside application, one more outer cover is there, that is called as class. Inside that only you will see. Inside that only you will be seeing all the attributes and functional components you're going to define and use it. Clear, everyone? Okay. So now in the real world business, if you look at a real world business and come to technology, take a business, implement a digital product for the business. So if banking application is a business, banking is a business, for that you create one application called as banking application. You are replicating the entire organization as one application here. Okay, entire company as application. Inside that bank, what will be there? Different departments will be there. What will be there? Different departments. What department? Account creation department will be there. Loans department will be there, and insurance department will be there. Cards department will be there. Each department, if you want to represent it in a digital form, then you're going to come up with what? Class. You're going to come up with class. So each class that you create is equivalent to one department in the real world. Everyone clear? Online students, are you clear?
Yes, sir.
Everyone of you, are you clear?
Yes, sir.
Okay. The tasks that are being done by the department are functional components. Loan department will be performing some number of tasks. No, those tasks will be done represented in a digital format like functions or methods, you call it as actually. Okay, clear, everyone? So the digital format of the physical business, okay, the entire business you represent it as a application. Inside the business there will be n number of departments. Each department you represent as a class. Each department is going to be controlled by some attributes and will have some functional tasks that are being done. So all the tasks that you are going to define inside class as functional components. Understand? Clear, everyone? Okay, let's keep this diagram here. And that's what about classes. So classes will be there inside application. So we got application created, we got classes also automatically created by application wizard. Not only created application wizard has created application, it has created organization, it has created operator ID, it has also created classes. Many other things we'll see going forward. It has also created so many classes. We will start using those classes going forward. We will also create our own classes as we proceed with our learning process in future. Okay, so classes are being created. Now if I want to create any functional component, where should I create? Inside a class. Inside a class only I should create. That will come under inside a class and inside an application. That we'll do practically later. Coming back to this one. See, classes are executable, right? I told. See, class is equal to one department in the business. Yes or no? That's what we are considering, right? Every class that you have here is one department in the business. In a business you have a number of departments. Tell me, all departments are executable units or non-executable departments also will be there? Meaning that I will tell you this way. See, a department is responsible for initiating a transaction. All the departments in a business system are going to be responsible for initiating some transaction, or there may be some departments which are going to provide some tasks, but those will not initiate any transaction. Will there be any such departments also in the real business? Will there be any such? Yes or no? Online students.
Yes.
There will be departments. Yes. Tell me one department in banking which will be having some functional components which will be supplied, but the department is not responsible for initiating any transaction. Suppose if I want bank account to be created, account transaction should be started, I will go to accounts department. If I want loan department will have the authority to initiate the loan transaction. Similarly, insurance. Tell me any other department which doesn't have any ability, which should not have an ability to initiate the transaction.
Sales.
Verification department. Which department? Verification is a department. Verification is a department. Okay. Verification is a department, means it is a class which will perform the verification, but it is not going to initiate any transaction. During the processing of transaction, somewhere in between it will come. It will supply the functional components which are necessary for verification to be done. Yes or no? So what functional components will be there here? Attributes. Attributes will be like
Proofs, Aadhaar, PAN.
okay. Details of customer. Details of whatever the transaction. Details of transaction should be there or not there. And mainly functional components are verification. Verify. Verify is functional component. Verify will give you back either success or failure. Success or failures. Accordingly, decision will be taken in the transaction. Okay. So like this, there will be some departments. Those departments are going to have some functional components, but those departments will not be having an authority to initiate a transaction. To initiate a transaction. Such departments are necessary in a business or not. Then how do you represent those departments here in the technology? You will represent those departments as classes only. You will represent those departments as classes only. That means in real world we have two types of departments. No? What are those two types of departments? Some departments which will have the ability to initiate a transaction, process and close it. Some departments which should not have transaction initialization capability. It should have or it should not have. Verification should have. It should not have as per the business. As per the business only, technology should provide everything. So verification department should be represented as a class, but the class should not be an executable one, meaning that class should not be initiating a transaction. It should not have any ability to initiate transaction. You have two types of departments in the real world. To satisfy the digital format of those two types of departments, the technology should also have two types of classes. How many types of classes should have?
Two types.
Types of classes. See, your entire technology will be evolved based on the real world business only. If they are creating technology like Java, C language, any technology, if they are developing the technologies, they will always make changes to the technology based on the real world. There is no technology in this world which is beyond the real world, which is beyond the real world. What is the need in the real world? What is the structure in the real world? Based on that, your technologies will be developed. So there are two types of classes. One is concrete class and the second one is abstract class. What is that? Abstract class. Abstract class. Okay, concrete class is the one where it will have a class is a class. No, if you remove the words concrete, abstract, what will be remaining? Class will be remaining. Class means attributes will be there plus functional components will be there.
Functional components.
Plus concrete class means transaction can be initiated plus transaction ID will be generated or not. Transaction ID will be there. Transaction will get closed here for sure. Then what is abstract class? Abstract class is also class only. Attributes will be there. Functional components will be there. For sure it will be there. But transaction cannot, understand? Cannot be initiated here. Transaction cannot be initiated means ID will be there or ID will not be there. ID will not be there for that. It will
ID
not
will not be there.
ID will be generated. Here ID will not be generated because this will participate in between actually. It will participate In between. Verification department is going to participate in between. No, I'm sorry. Where is the diagram? Verification during the account creation process, loan processing and insurance processing, after initiation is happened, then somewhere in between verification will come into picture. Now we will jump into another one. So everyone clear about types of classes? Types of classes are two types, concrete and abstract. Concrete classes are abstract. Both will have attributes plus functional components. But concrete class is the one transaction can be initiated. Abstract is the one transaction should not be initiated. See, in the real world, there are some departments where transaction initiation should not happen. There are some departments where transaction initiation is required. These departments you are representing as classes. How do you represent these departments as classes now? As you have two types of departments, you need to represent two types of classes, where classes with ability to initiate transaction, classes without having ability to initiate transaction. So classes with ability to initiate transaction are concrete classes. Classes without ability to initiate transaction, you will represent them as abstract. Make sense? Clear everyone now?
Yes. Yes, sir.
Yes.
Yes, sir. Okay. Okay. Now, next topic we are going to discuss about is inheritance. When we discuss about inheritance, we will come back to abstract classes once again. Okay. Inheritance. Inheritance is a concept. It is a relation. It is a concept that is relation defined between classes, between two classes or more classes. Okay. The relation makes it possible to access the components of one class into another class, In inheritance concept, one class is going to act as a parent. One class is going to act as parent, and other class is going to act as child. Okay, the base class is parent. The base class is parent class, whereas inherited class, okay, the class, whereas the class inherits from base class, is called as child class, Now child class can access the components of parent class, but not vice versa. Means parent class cannot access child class features. Okay, father money will be accessible to son, but reverse is not possible. Okay, that's how. Okay, so multiple parents can be there. Parent one has child one has another child, grandparent, parent, child. Child can access parent property as well as grandparent. Child can access parent property as well as grandparent. Why this concept has been brought into technology? So in technology, anyhow, classes are there. Each department you are representing as a class. Okay, but why they had introduced or designed another concept called as inheritance concept, where the relation defined between the classes to allowing to access the components of one class to another class. This is to achieve inheritance, is to achieve reusability. What is that? Reusability, comma, to avoid redundancy. What is that? Redundancy. And easy to extend and all will be there. I will tell you. Look at here. See, coming back to our diagram. Verification is a verification tasks. Verification tasks are needed for account creation, loan processing, and insurance processing. All these three require same verification task, yes or no? Yes. So verification is a department which is commonly needed for account creation department, loan department, as well as insurance department. So verification task you are creating. If you create a verification task, you can create in 3 of the classes. You can create in all the 3 departments. All 3 departments you can have necessary components related to verification. But how many times you have the components in the bank now? 3 times you have same components. 3 times you have same components. Instead of that, create a separate department for verification and give access to this verification to all the 3. How do you give access to all the 3? By defining inheritance relation. That is, your verification department is going to be accessible to all the below departments. How do you access the verification components at runtime? Into account creation department and into loan processing department and into insurance department. When you do what? When you do inherit. When you do inherit, this is inheritance relation. Inheritance relation. This one is called as inheritance relation. Understand clear, everyone? So inheritance relation should be defined between the classes. That is a necessity in the real world. That's a necessity in the real world. So now verification class component should be accessible to account creation, loan processing, and insurance processing commonly. Then how can I access? Account creation can inherit from verification, loan processing can inherit from verification, insurance processing can inherit. When inherit only it can access. No need to create again and again 3 times. Instead of that, create at one place and access at all the 3 places. Tomorrow, if a new department is being set up, again for verification, you don't have to create components. That is going to make your task easy. Understand? This is the real need of inheritance in the real world business. Everyone clear? Why inheritance is needed?
Yes, sir.
In the real world, there will be some
Sir?
common features which are needed for different classes. So common features you place in the parent class and allow the child classes to access by defining inheritance relation. Okay, which is making your task easy. No need to create the same component redundantly again and again. Easy to extend in the future. What is the question you are trying to ask?
Sir, while opening account creation or loan processing or insurance processing, every time it asks a verification when you create inheritance.
Whenever you are creating account, whenever you are going through loan processing or insurance, somewhere at some point in time it requires verification. Then it will take the components from verification class and finish the verification part. Understand clear, everyone?
Yes,
Means
sir.
we don't need to create again and again.
No need to create again and again. See, it's all about how you organize the things. If you create at 3 places also, okay, no problem. Your business will run successfully. Why should I write the same logic 3 times? Why should I write 3 times? I'll write only 1 time and access it commonly to multiple places. For that reason, you need inheritance. So this is called organizing the things in a proper manner. Okay. So you will always create your application, functional components, everything with a sense of reusability, easy to extend, avoid redundant work. Avoid redundant work. If you want to achieve all that, you need to come up with some concepts defined like this. Understand clear, everyone? Online students, are you clear with this point? Now, in that case,
Yes, sir.
verification department, is it going to be abstract or concrete? Abstract or concrete?
Abstract.
Going to be abstract class. It's going to be abstract class for sure. There is no doubt about it. Yes or no? It's going to be abstract. Then what about the below? These are all
Concrete.
Concrete.
classes. These are all. So
Concrete
from
class.
here, I'm telling you something. Usually abstract classes are parent classes. Concrete classes are child class. Can a concrete class have another concrete class as a child? Yes, possible.
Yes.
Inheritance relation is not between abstract and concrete. Between 2 classes, that can be any combination, no issues, general. But in a real world business structure, everywhere, wherever you see, if you bring that into technology, usually the structure will be like abstract classes will become parents and concrete class will become children.
Yes.
Understand? That's how a usual structure you'll get. I'm not saying it is mandatory to be abstract above, concrete below. Okay, usually if you take any real world business, 100 out of 100% real world businesses you take, 100% all the abstract classes will be on top. Abstract departments will be common departments. Those will supply components to other individual departments which will perform the transaction process. Usually those will come at the top level only. Understand clear everyone? So this is inheritance relation defined between classes. You have to define. So the thing is, as a developer, you need to learn the business structure, business architecture you should learn. Okay, after learning the business architecture, you are a developer, you have technology knowledge, right? Technical knowledge. Now aligning with the real world business, you implement something using your technology. It should match with the real world setup. So your technical development should exactly match with the real world setup. Understand clear everyone? If it is not matching, your business will function in a wrong way. Your business, real world business setup is different. Your technology setup is not matching. When it is not matching, is it going to function the same way how it works in real world? So you are saying, I want to develop real world applications and all, right? What do you mean by developing real world application? The business that is running in the real world, same architecture you want to bring by using technology. That's what called as real-time application. Yes or no? Okay. So that's what your technology should always represent something which is matching with the real world. If it is not matching, means your development is wrong. If it is not matching, means development is wrong. That will create losses for your business. Make sense clear everyone? So at the time of creating some components, something, we should always think about the real world business, understand it, and then create here. That's the point of. Okay, everyone clear? Online students, are you clear? So far, are you clear?
Yes, sir.
Yes, sir.
Yes, sir.
Inheritance concept is over. Inheritance in Pega, I'll come to that. Okay. So before I come to inheritance in Pega, we need to learn so many things in Pega. Probably inheritance in Pega, I'll take it tomorrow. You understand generally inheritance. So I will tell you one point in the inheritance once again. A is parent of B and B is parent of C. C is parent of D, which means that D can access C as well as B as well as E. You need to remember this forever. See, I have posted one question in Instagram. I'll read out now. Okay, I'll post, you follow. Okay, and try it. Okay, I have posted one question in Instagram asking that if we have two classes, okay, you don't know about Pega inheritance, right? If they know Pega inheritance, if you know Pega inheritance, then you will be able to solve this. The question I have posted related to inheritance. I am not telling the question because you are not having knowledge on this. I'm not telling. Tomorrow I'll tell you the question. Okay. I posted this question in Instagram with the diagram and all. I was asking something there. When I asked something there, I got around 14 comments. How many comments I got? 14 comments. You know what? 14 persons answered same answer. 14 people have given same. I have given option A, option B. 14 out of 14 told me option A only. Okay, they are right as per their analysis. They are wrong as per the technology. 14 people give an answer. This is the basics of Pega, right? Inheritance means basics of Pega or something advanced topic. Basics only, right? Basic topic, one question is being asked. Question is being accessed by around 3,000 people. Okay, I mean like 3,000 means duplicates. If you remove 1,500 have seen the question. 14 have attempted giving the answer. 14 have given same answer, but 14 are wrong. Okay, tomorrow I'll tell you what is the exact question after this topic is over. This topic will take half an hour time to explain. That's why I'm not starting. See, the problem in Pega market especially is even real-time working employees. Even with real-time working employees means real-time working employees means who? Okay, you are a fresher. You joined Pega today. You spent 3 years back. You joined as a fresher. College pass out as a fresher. You joined Pega project. You worked for 4 years. You don't know basics. That's the problem in real world of Pega. Why you don't know basics? You are not researching. So many people 99% of the people who are working in Pega world, they are not understanding Pega. They don't have a clear-cut understanding of Pega about the right things in a right way. Okay, many people are believing wrong answers are right. So you will come to know what exactly is the correct one only when you have done some research on your own. Okay, so I just asked you a question. Parent of parent is parent, yes or no? Parent of parent, A is parent to B, B is parent to C. So parent of parent is also parent, yes or no? That is a universal concept of inheritance. That is also applicable in Pega, but there is some limitation in Pega. Okay, when it comes to Pega, some limitation. People do not know about that limitation. That's why they all said accessible, accessible, accessible. All 14 said accessible only. The answer, whatever they have given, is correct as per the inheritance concept universally. But the answer they have given is wrong as per Pega. Okay, that we will see. Tomorrow we'll see that for sure. Tomorrow the concept is over. Immediately I'll post the question to you. You only think and tell me. You will also tell us them only. Whatever they said, you will tell me the same thing. Okay, we will see. Okay, so now that's what I want you to learn it in a proper way, which is actually correct as per the tool. Okay, don't learn the wrong things. 99% of the people learning wrong by learning from the wrong tutors. That's the problem. It's not about the student. You ask their trainers also, they will tell the same. You ask a team lead or tech lead, they say exact same answer. They will say whatever the 14 people have given. 99.99% of the candidates who are working in real time, they'll say the same answer, but I can prove that is wrong. They will also realize afterwards. I'll make next video, no? Then they'll come to know. Next video I'll make giving the answer. Then they will come to know. Okay, with the proof I will make it. Okay. Okay, so I want you to learn it in a proper way. What is right, what is wrong, you should know. This is one example. Like this, there are so many concepts where people have misconception and misunderstanding. The concepts, they are understanding it in a wrong way and they are interpreting in a wrong way. Okay, you need to learn it in a proper way. We will see that, no problem. And here you go. This is what about inheritance. Everyone clear about general inheritance concept in OOPS? We are now going to jump into Pega. In Pega also, Pega is built based on core engine is built based on Java only, right? Everything that you develop in Pega, you will follow object-oriented programming structure only. When you are following object-oriented programming structure, you need to think about all these points always. Advantages of inheritance. Okay, not only inheritance, generally, you from beginning day one to day end, you should keep in mind these things. Anything you are doing, keep in mind reusability. What is that? Reusability. Something you are doing today, you think about future whether it is useful or not. I told you one example. You are purchasing a dress for 3 years kid. Usually parents will think about we'll buy it for 5 years kid so that it will be useful in future also. One time only we are wearing. 3 to 5 it will easily go. So they will grow super fast. At the age of very babies, growth will be at a high rate. Yes or no? So it's better we buy 5 years fitting cloth, so I can utilize it. Reusability without simply throwing away. So reusability you should always think about as you think in personal life. One component you are creating, think how can I reuse it in future? Will this be reusable in future or will not be reusable? So you need to place it in an appropriate position. Reusable means you need to place at appropriate position. So you want to bring, I wanted to provide you water. Water is useful for everyone. Is it necessary for everyone to share? Not necessary for everyone. Only one person means I'll give a bottle, done. I'll give one water bottle for only one person. I want to supply everyone means it should be reusable, no, to everyone. I'll put a water bubble and dispensing machine outside in a common area. Everyone can have. Where you position it. Okay, in which position you are going to place is most important thing than what you are creating. What you are creating is one thing. Okay, but where you are going to position this component in your application is most important thing to know. Based on where you position it, you will achieve reusability. Yes or no? If I am placing a water bottle at my desk, will you be taking it? You are not taking it. It is not reusable. It's my personal. If I am placing a water bubble at the outside in a hall, you all will be going and utilizing, no? So where you position it is most important. My intention is all of you want to use it, but I am placing here beside me. Is it a right position? No, it's not a right position. So you are not going to think as a simple developer who knows development of something, navigations and all. You should think like an architect. You should think like an architect. Think about reusability. Keep in mind reusability and no redundancy. No redundancy. Today, the component that I am creating should not be recreated again and again. These two are related. Reusability and no redundancy are related. Okay. And think about always easy to extend your business. Easy to extend the business. Okay. Think about no rework. No redundancy means no rework. No rework. No rework should be there. Okay. And financial benefit, time saving and financial benefit. You should always bother about all of these things. You need to keep in mind. Obviously, if you achieve reusability and no rework, you will be saving the time. You'll be getting the financial benefit out of it for sure. Okay, clear everyone? So keep in mind about all these things. To achieve all these things, we have different the concepts like inheritance. The concepts like inheritance is there. That's the inheritance is very, very important. Inheritance is going to save your time, save your money, and it will allow you to not redundantly perform a task. You are not performing task redundantly. That will be made by inheritance only. It will allow you to reuse a component. It will allow you to reuse a component more than at one place. More than one place it will allow you to reuse. All these are been advantages of inheritance. That's why inheritance is a core fundamental concept in an architecture point of view. In architecture point of view. So you want to be an architect, you need to be good at the fundamentals. This is why I am telling you are good at fundamentals, then you are going to be a tech lead. You don't know inheritance, but you know development. You know how to develop, but you don't know where to place. You are going to be just a developer, or you are going to be an architect. Developer only. You'll never be an architect. You know how to construct brick by brick. Okay, place one after other, but you don't know the appropriate position to place these things. Okay, a engineer will come and tell you construct this here, construct that here, position this here, position this here. Whatever the position that they tell, we will do go and construct there. These people are called as employees, and that is called as architect. Who will be paid more? Architect only. Architect always works on fundamentals, strong at fundamental. Architect also knows construction, but architect knows about the fundamental architecture, fundamental properties of the whatever it is, respective entity or whatever it is. So learn the fundamentals properly, then you can be number one in the technology and in the IT field. Okay, so that's why always keep in mind about inheritance structure. Okay, do not create everything in single class. Don't do that. Think about reusability. Divide your single class into multiple classes. Reusable components place in parent classes. Normal other things you place in child classes. That's the way. You should not come up with everything in one single unit. Divide into smaller units. Connect all the smaller units. To connect, you need inheritance. Understand? This will save your time, money, easy to extend, and no redundant work and all. And also you will achieve reusability. Make sense? Clear, everyone? So tomorrow, April 12th, sorry, April 12th, that is 2024. Inheritance in Pega. Inheritance in Pega. But before we see inheritance in Pega, the classes created in implementation application, comma, their types, and framework application and their types. These things we need to make an observation with screenshots. After we make an observation and understand the things, then we will go with this inheritance in Pega, layers of classes. 3 layers.
Sir, yesterday did we study only creating implementation on top of the framework?
Yesterday we just have created implementation on top of framework. That's practical yesterday. As a
Okay, sir,
result of
because
yesterday, what is
because I only checked the reference video, so I wanted to confirm what was covered yesterday.
hold on. To understand whether I am listening to you or not. The voice is not clear. There is a lot of noise. I'm going to mute. Unmute back once again from your end. Ask. Unmute now and ask me. There is some background noise coming.
Yeah, sure. So yesterday I just went through that reference video from the old batch, so that's
Yes,
the
yes.
reason I
I
just
forgot to
wanted to
record.
confirm what was covered yesterday.
Exactly the reference video, what is there, that is being covered. That's why I
Creating.
that. Okay, same thing. Implementation, application creation is been covered, but class names are different. Our application is Tata. There I might have given some other name. The name only will change. You follow our application name Tata and all by document. You have document.
So object-oriented programming language. This is you started only today, right? Sir?
Today only we started with oops, and then oops is over. We are jumping into Pega. So after we create application, classes are being created. What are the important layers of classes created? Inheritance we don't define here, already defined. Everything Pega knows what to do, but we need to realize to understand what it has done. So tomorrow, analysis of what is being created. Okay, already something is being created. You are analyzing it to understand. After that understanding is over, then only we will get into practical part further. Okay, because without understanding that, you cannot get it. Okay. Okay, you can wind up for today. I will be attaching the documents. Today's session is recorded. Every day, just before the beginning of the class, remind me that I have to record it. Okay, thank you. Yes, please. What is the question? This is what encapsulation. This is what encapsulation. This abstract classes is abstraction. Polymorphism will come in future. Okay, thank you. You can wind up for today. We'll continue tomorrow. You need to fully focus on these fundamental concepts. Fundamentals, you are good. You are going to be an architect. Understand. Thank you.